Okay, I'm going to do an example for you of calculating the time when the voltage is equal to 10% of initial voltage across a capacitor in an RC circuit. Remember, an RC circuit looks like this. You saw it in lab, we talked about it in class. And the capacitor has an initial voltage across it, we'll just say as V0. And then slowly, the voltage is going to drain away. And we were interested in how long it's going to take for it to be 10% of the initial voltage. I'm going to say V0 is equal to 10 volts. And I'm going to say that C is equal to 1,000 microfarads. And that R is equal to, I'll take R to be 2 mega ohms. All right, so it's a big capacitor and a pretty big resistor. They're both big, so it's going to take a while here. But remember, if we were interested in the voltage at 37%, how long that's going to take, all we would have to do is multiply these two together. And if we convert this to farads and that to ohms, multiplying them together gives us seconds, which was very interesting. Some of you were really amazed by that. But when we're going to 10%, you can't just multiply the two of them together because that tells you how long it's going to take to get to 37%. So we're going to have to go a little bit more step by step to find the 10% voltage. So I'm going to write out the equation for the voltage across the resistor or the capacitor in an RC circuit that's been discharging for a period of time t. This is the initial voltage across the capacitor, and that's the voltage across the capacitor and the resistor at time t. So what I said here is 1 volt is equal to 10 volts times e to the minus t divided by RC. So what I'll do is I'll divide both sides by 10 volts. And what that gives me is that 0.1 is equal to e to the minus t divided by RC. Now to solve a problem like this, what I want to do is I want to take the natural logarithm of both sides. Since they're equivalent, the natural logarithm of both sides should be equivalent. Now the natural logarithm of 0.1, if you look it up, is minus 2.306. Anything less than 1 is going to have a natural logarithm that's negative. And on the right-hand side, the natural logarithm of e raised to any power is that power by definition. So that's easy. And then I also know that there's a negative sign on both sides, so I multiply it by -1, so they're both positive now. Then I'm going to solve for t, so I'm going to multiply this side by RC, multiply that side by RC, and I have that t is equal to 2.306 times R times C. Now let's put in our R and put in our C. R is 2 mega ohms, so it's 2 times 10 to the 6th ohms. C is 1,000 microfarads, which is 1,000 times 10 to the minus 6 farads, or 1 times 10 to the minus 3 farads. So R times C is equal to 2 times 10 to the 3rd, it's going to be seconds, or 2,000 seconds. So therefore, the time it takes for this voltage to drop to 1 volt is going to be 2.306 times 2 times 10 to the 3rd seconds, which is going to be about 4,600 seconds, or 4,612 seconds. So it's going to take quite a while, but this is a big resistor and it's a big capacitor, so charge doesn't move all that fast to leave that capacitor. and get to the other plate of that capacitor. And I might have asked you this question, said, okay, how long until until V is 37% of V0. And you know you could just multiply R times C, but I'll show you why that's the case. So 37% of V0 is 3.7 volts. That's what V of t would be. So in order to find that time, I would say, okay, 3.7 volts is equal to 10 volts times e to the minus t divided by R times C. Divide both of these by 10 volts. And I have 0.37 equals e to the minus t divided by RC. Take the natural logarithm of both sides. Do it in black. And I have natural logarithm of 0.37 is really, it's -1. If I actually took 0.368, which I should have done, it would have been -1. 0.37 is like -0.9983 or something like that. And again, on the right-hand side, I have e to the minus t. Whoop, the e is gone because I took the natural logarithm of it. I just have minus t over RC. By definition, natural logarithm of e raised to something is just that something that the e is raised to. And then, so that means I can multiply both of these by -1 and multiply them both by R times C. And I get that T is equal to RC, which is, in this case, about 2,000 seconds. All right, so that's how I get the fact that I can just multiply R times C, because the natural logarithm of 0.37, or 37%, is -1, and multiplying everything together, T is just equal to R times C. Okay, that's it for now.